everybody. In this video, we are going to talk about some of the more complex Lewis structures. In the last assignment, you were working on just single bonded compounds, and we're going to introduce how to figure out when to use more than just single bonds. So I'm going to start off here with HCN. As you can see, I've already got my Lewis dot structures drawn. That's always our first step. We know that hydrogen has 1 valence electron, carbon has 4, and nitrogen has 5. So that's our first step, is just drawing out those original dot diagrams. Now, we know that every element wants to get to that octet, although there is a little bit of an exception. Hydrogen does not want to get to 8 electrons. It's happy with just 2. So hydrogen in this structure is going to need to share 1 electron from carbon or nitrogen. The question is, which one does it borrow from? But we know that hydrogen needs to make 1 bond in order to get to its 2. Carbon, on the other hand, has 4 valence electrons, which means it needs 4 more in order to get to 8. So carbon needs to make 4 bonds. Lastly, nitrogen has 5 valence electrons. In order to get to 8 valence electrons, it's going to need to make 3 bonds. Now, a helpful clue that I have for you is don't try to split up any lone pairs. So I recommend just leaving those lone pairs on their own, because then if you notice all of the lonely electrons, like hydrogen has 1 and it needs to make 1 bond, carbon has 4, it needs to make 4 bonds, and then nitrogen has 3 solo electrons and it needs to make 3 bonds. So that's kind of like a clue or a hint that will help you figure out how many bonds does each element need to make in the compound. And so this actually kind of works out how it is. Nitrogen has to make 3 bonds. Carbon has to make 4. Hydrogen has to make 1. Well, 1 plus 3 is 4. So if the hydrogen bonds to the carbon like so, then the hydrogen will be happy. It's now got its 2 valence electrons. We've got hydrogen with 2 valence electrons bonded to carbon, but the carbon still needs to make 3 more bonds. Luckily, the nitrogen also needs to make 3 more bonds. So we can go ahead and pair up, although this is going to look kind of sloppy, we can go ahead and pair up those last 3 sets of electrons between carbon and nitrogen, giving us a nice triple bond. And then we just drop in our last lone pair, making sure that everybody's got 8 valence electrons. Now, as you can see, we've got the hydrogen has 2 valence electrons, carbon has 2, 4, 6, 8, nitrogen has 6 from the triple bond, and then 2 from its lone pairs for 8. So that's a short example there. Now, something that does get a little bit more complicated is this one here, HCOOH. Now, the way that it's written is kind of a clue. Again, as you can see, I've already got all of my Lewis dot structures drawn. We know that hydrogen has to bond to one other element, and in the formula, it says HCOOH. Why isn't it just written H2CO2? That's the clue that one of the hydrogens is bonded to a carbon and the other hydrogen is bonded to an oxygen. The problem is, what do we do from here? We know that this carbon needs to make 3 more bonds, and the one oxygen needs to make 1 more bond, another one needs to make 2 bonds. So we've got 1 and then look at that, 3 more solo electrons on oxygens that need to be paired up. And wouldn't you know, carbon has 3 solo electrons. So I'm going to go ahead and pair up 2 pairs with 1 oxygen and then 1 pair with this other oxygen. Now, when I simplify this, what this ends up being is hydrogen single bonded to carbon. This carbon is actually double bonded to 1 oxygen, but then single bonded to the other oxygen. And then that oxygen is single bonded to the hydrogen. And then we just include all of our lone pairs. And this is our nice final clean structure. So things do get kind of complicated. My number 1 recommendation is if you are stuck on a problem, then just leave it, come back to it. All right. So if you get stuck, sometimes it's just that maybe you're just not really seeing how everything clicks. So just take a break, go to another problem, then come back to it. And if it doesn't work the way that you first try it, try reordering the way that you drew the initial dot diagrams. I drew the hydrogen, carbon, and oxygen atoms in such a way that I knew it would be easier to bond. But that's because I'm the teacher here.